What we're going to do now for the next 20 minutes is hold a discussion session. What we are going to do is invite back all of the speakers from today. And as we're inviting you back, we will also be making you co-host so that you will be able to unmute yourself. Give us a moment while we do that. I see that our fearless leader, Fumiya, is here. Fumiya, did you have particular questions, or how should we proceed?
Yeah, well, I think first of all, I think we should just ask anyone question, like urgent, questions to ask to everyone. I think it's the goal of this workshop and this discussion in particular is kind of trying to build up some integrative views on embodied intelligence, and we have all experts in all different fields, and I just want to hear what people think I can contribute to develop some integrative views. Anyone have ideas how we can start a discussion like that? Maybe you can ask Josh to kick off.
Gosh, I don't know how to kick off except to just continue on from what we were just discussing. I think this connection between the connectome and body structure in space and time, clearly there's much work that could be done there. And we've heard lots of other points of contact between neuroscience, psychiatry, mathematics, formal approaches, philosophical approaches today, and also contacting the nuts and bolts of robots and biological systems. Clearly many points of contact. Maybe we should proceed by asking people to raise their hands. Again, if you click bottom right, there's reactions. You can raise your hand or clap. We'll see the icon and just call on you. Andy, I see your hand is up.
Oh, hi, yeah. This is just coming in on Olaf's talk, which was wonderful. Thank you so much. You talked a bit about spontaneous cortical activity and also about the place of generative models maybe in this kind of framework. And there's quite a lot of people, I think, out there that think that spontaneous cortical activity kind of reflects the predictions being made by an internal model. So there's a way of maybe linking up these bits of our discussion directly through that. There's some nice work on ferrets, for example, showing them movies and then seeing whether the spontaneous and sort of caused activity starts to line up after learning about natural scenes.
Completely agree, and I think that's the link that I was hinting at. I think it is notable that spontaneous activity has not been gotten rid of in the evolutionary setting. In fact, it's been elaborated, if anything, and is taking up, 80% of the energy that we feed our brains goes into that. That's the rough estimate. I'm just wondering how people in embodied intelligence or on the robotics side feel about this. When I kind of left robotics behind and pivoted over to connectivity full time, there was a lot of hesitancy or resistance in the field towards any kind of internal representation, okay, or anything that goes on between the ears, so to speak, that's not tied to the body. And I wonder where the discussion stands now that I'm looking back at it after a dozen or so years. Has that, what do people think these days about the importance of internal models in guiding action? Again, when I was, some people I interacted with at the time, Andy, perhaps you remember, were quite hostile to the notion of any kind of internal model, okay?
Yeah, I mean, I think that these prediction system things are actually closing that gap somehow. It doesn't look like the kind of internal model that gets in the way. It looks like the kind of internal model that's just part of the perception action loop when you're projecting just a little way into the future.
I think there's been very much a pragmatic turn. If your AI or your robot can, avoid going off a cliff without self-models, great. If it needs a self-model or some sort of internal model to get the job done, then fine. I think a lot of these philosophical sticking points, have been overcome by, the pragmatics of real-world machines operating in the real world. I think Carl would like to add something.
Well, just to reinforce what you just said, and both Andy's point and Olaf's point. It, so when we talk about generative models, well, when Andy and I talk about them anyway, we actually include the body. It doesn't just have to be a brain, you know. So one phrase is that the agent entails a generative model. So a virus can have a generative model without having a brain. But it strikes me that that notion that generative models don't get in the way anymore, I think it's really important, because it also speaks, Josh, to your question. You know, how can you integrate the embodied aspect, even its radical versions, with some of the more high-end, you know, liking, motivation, curiosity, epistemic affordance. I think you can do that through the structure learning of generative models, which speaks exactly to the structures that underwrite the nature of a connectome. And more specifically, the whole point of structure learning is to match, to use Olaf's word, the internal model to the sensorium, or the things generating that sensorium. So, you know, that structure learning, that is all about matching the brain to the body and the body to its, you know, its situated, is, I think, that, you know, the way that you can bring all these things together. And in that spirit, you know, I've always thought that soft robotics is, you know, I've just been waiting for it to happen. It's obviously the way forward. You know, we live in a soft world. Our world is populated, you know, by creatures that are soft, like pets and people, and viruses. So it's obvious that, just, you know, referring back to the origins of cybernetics and the good regulator theorem, you know, that is almost provably true, that if you are in a world that regulates you and you regulate, then you have to be a model of that world. It's obvious to me that soft robotics is the way forward. I mean, it can't be anything else. So is that why you left, Olaf, do you think? They weren't soft enough for you when you were younger?
No, I think it was, in my case, pure opportunism, because connectivity took off, as you remember, in the mid 2000s, and it was just too tempting a target to leave behind, and it took up all of my energy. But I, you know, yeah. Anyway, that's yeah. I agree with what you just said, Carl. A soft world, some people's worlds are softer than others. All I can say. But yeah.
Nicholas, I think put the cream on top here by distinguishing between having an internal model and being a model. Great way to put it. Nihat, you've had your hand up for quite a while.
Yes, that's true. So I want to discuss a little bit the difference between prediction and anticipation. So we talk so much about generative models, and so the question is whether it is really necessary to generate, so to say, a prediction, a sample, a potential evolution into the future, or do I just need to build up some kind of expectation, which does not necessitate to actually generate a sample of a potential future? I think if I want to evaluate my surprise, which is important in this predictive coding context, it's not enough to have a sample. So just generating a simulation of the weather in 3 days, let's say, will lose the information about how much I will be surprised when I see the rain. So I really have to propagate the whole distribution. And there are two ways to do it. One is to do many samples and to, so to say, have some kind of frequency at the end of the day of all these samples. And that would be the basis to evaluate size. But with one sample, that will not be the case. My question is whether there is a shortcut that does not necessitate an actual simulation of a potential future trajectory in order to evaluate your surprise. So is it really necessary to generate with a generative model, or is there another way to do inference? And I think this relates to really prediction, which would refer to an explicit generation of a future trajectory, or anticipation, which only requires my expectation. So do you make, I think maybe this I would like to know opinion of Carl Friston and Andy Clark on this, whether, I mean, this notion of generative model is so central in all our discussions, but I really don't know what it means.
Well, I thought it was an excellent question. So the predictive coding gloss would say that the prediction is the prediction in the moment, that if my hypothesis about what caused this data was right, then I would predict this particular pattern of information, and I use the prediction error in the moment. And that would be a perfectly apt description of a thermostat or a virus, and possibly even higher forms of life, that they live in the moment because they're just predicting what would happen if my entailed generative model, subpersonal, implicit generative model, was fit for purpose to model my regulated or controlled environment. The move to anticipation is absolutely crucial from the perspective of this notion of planning. And planning brings with it the expected free energy, it brings with it the active inference, it brings with it agency, it brings with it temporal depth. All, as soon as you talk about anticipation of things that haven't yet happened, you bring to the table a whole realm of sort of more human-like or more generalized artificial intelligence-like things to the table. So then we come back to Andy's emphasis on the active aspects of perception, and that the consciousness is in the doing. But in the doing, of course, the consequences of doing are always in the future, which brings us back to your key question, the fundamental difference between anticipation of what could happen if I did that versus prediction, what is happening given I predicted that the world is in this state.
I think we have to distinguish also between, there are stochastic self-models, which capture in one model all the variability, very different than a filter or a group, and also there are conditional self-models, which we can capture, a lot of what if, if I do this, then that's going to happen. So you have conditional, you have stochastic. So the whole notion of self-model and anticipation prediction is I think a very broad area. I wanted to say one more thing with regard to discussion earlier about, the place of these models. Historically, there's been a lot of manually defined self-models or simulations, and that was sort of historically where there was a lot of friction between the machine learning and between the sort of spontaneous systems versus the pre-programmed systems. But increasingly, we are now seeing self-models that are learned. In other words, it's somewhere in between. It brings in machine learning, but it also brings model-based behavior, the old school robotics. So machine learning has moved in the last, I'd say 10 years, suddenly to be able to create self-models that are good enough that you can do a lot of interesting things. And this is why suddenly they don't get in the way, they actually help. So it's a sort of a historical progression.
I see that Simon McGregor has his hand up. I'm not sure, Simon, if you can unmute yourself. If not, you can type your question into chat.
I can unmute myself, sorry. Yes, so I had a question. Embodied cognition tends to focus on embodied competences and near optimal sensory motor cognition. But humans, and presumably other animals, require real-world time to process sensory information. Cognition, even in firmly embodied systems, sometimes, as it were, involves sitting and thinking, and always involves processing delays. How close are we to a properly embodied picture of this sort of, I'm going to call it, thought?
Any of our speakers would like to respond to that?
Well, I would say just that creating the self-model might take a lot of time, but using the self-model can be very, very rapid. You can have a very long learning process. Maybe as a child, it can take you days, months, weeks to create the self-model, but you can use it instantly when you're about to fall over or something like that. So we should distinguish between the learning and the using. So That's one important angle. And again, you can learn things faster, but you can use them at a completely different time scale.
I think robotics also offers some unique perspectives on this. I mean, we're already now moving into the Internet of Things, where we have, cloud servers out there that are training deep networks all the time, and they're instantiating, trained networks into, drones and autonomous cars, you name it. So humans might have to act and think separately, but with machines or a network of machines, that might not necessarily be the case. You can think and act simultaneously. So it's kind of interesting to think about where robotics and IoT and machine learning is going. Is the embodiment, at least at the very large scale, may look very different from this large scale embodiment. Carl, I think you had your hand up first.
Yeah, very briefly, I noticed in the chat someone was asking, has anybody been using free energy in robotics? And they have. And the thing that makes it work speaks to Simon's question. They amortize the inference. So they use deep learning to learn how to infer. So just to reinforce Hod's notion that learning has got a really important role to play to learn how to infer online very, very quickly. And I also noticed there's a mention of heuristics. So in the language of generative models, heuristics are those minimally complex priors that can be learned. So I think it all fits together quite nicely with the simplexity perspective.
Andy?
Yeah, so this is just a quick follow-up with Simon there. So one place that those links might get built is through attention, I think, that, as it were, all of these mental activities involve flows of attention. And attention, I think, in turn, is probably sculpted by our bodily capacities in many ways. So I don't think it's certainly not something that's well understood, but it does seem to me that there's some relationship between what I can deliberately attend to and the kind of capacities that I've got to sort of, look around, flick my eyes around and so on. So even when I'm doing covert attention, I feel like those circuits are somehow in play. Attention in predictive processing is a bit bigger than that, and it can kind of get assigned to things where I don't have any bodily kind of abilities to sort of use that as a mode of deliberate attention. But I feel like there's something there. I'm not quite sure what it is.
Lee asks in chat, can attentional capacities be optimized? Any takers? Carl.
Yeah, sorry, I'm dominating. I shouldn't. I've got to go do a pandemic podcast in a few minutes, so I just apologize as well. I'm answering for John. So John Tani would have said, if he was here, yes, that's his W. So it's precision. It's the strength of the coupling or the message passing at different hierarchical levels of the model.
Thank you. I want to return to something that Olaf mentioned at the beginning of his talk, which was individual differences. And I think that this is kind of interesting. Daniela mentioned earlier in the day, the possible future for robotics, where we're going to deploy physical machines that have very, very different embodiments. I don't really have a question, but I just thought it would be interesting to return to that. How are we going to grapple with, the Internet of Things or robots that have very different body plans from us? They may form very different internal models. Does this complicate theory of mind from bio to machine and vice versa? I think there's a lot to think through here.
Josh, you hit on, I think, one area where there's a lot of misunderstanding. I think in the general public, people talk about AI and robots as if it's one thing. The reality, it's a species, it's an ecology, if you like, of robots and AIs and body plans, each one of them having a different experience and so on. So you get, you get a huge diversity of abilities and experiences and capabilities, which in many ways reflect the biological world. So it's in one sense very interesting. But the one thing that is different about these robotic systems, which you alluded to earlier, is this hive mind, right? Because you can more easily transfer a mind from one robot to another than you can do between animals or humans. There is a potential you know, if one robot gets better, then all robots get better because it can share its experiences with all the robots instantaneously. We have no intuition about the effect of that scaling because that doesn't happen in biology. We don't drive cars better because there are more drivers on the road. We drive a little bit worse. But driverless cars, the more driverless cars there are on the road, the better each one of them get. This is a very, very unnatural thing. And we have a hard time understanding that kind of scaling. So, so we'll see how it plays out, but it's going to be difficult to intuit.
Agreed. It's going to be a brave new world, whichever direction we head in. I think maybe this is a good point again to pause, and we're going to shift now from open discussion to the breakout sessions. I'm going to hand the baton over to the organizers and explain how that's going to happen.
Okay, yeah, thank you, Josh. I think this was great discussion, and it's actually the beginning of discussion. We want to continue this discussion later today, also tomorrow and the day after. So please keep joining us with all this discussion. So this is the end of the first day main session, and we still have a breakout session from now on, and you're all welcome to join the breakout sessions. But we will see you all again tomorrow morning at 8 a.m. GMT. So hopefully we'll have a lot more people joining in addition to those who are joining today.